stage. We've got time for questions and maybe some answers. Any questions? Okay. Yes, ma'am. Oh, the question was, Cacao, I mentioned that he said something related to Neil Armstrong, and Neil Armstrong made a speech when he stepped on the moon, you know, small step for man, giant leap for mankind. And Cacao said, one small step for a Japanese astronaut, and a giant, and they paused, and they said, entrance into the space program. And so we kid him a lot that, you know, it wasn't entrance, it was a leap. You know, but anyway, Cacao, you know, he has a thick Japanese accent, but he speaks English a lot better than I speak Japanese. So, you know, we didn't have a problem with that. Anybody else? Any other questions? Come on, you kids. Oh, yes, sir. The question was, how much do they charge us for extra baggage? And that's actually a longer story than I'll go into, because we have rules on what you can take up with you, and I exercised the full extent of those rules. Probably a little too much, so next time I'll probably stand a little bit further from the line on taking stuff up. But I did the baggage. I got to take 2 items that were personal items, and as long as they were reasonable, I could take them. And I took my dad's Rotary hat and the American flag. Rick Linehan took the Kermit. And then I think he took a hockey puck, was his other item. And then we were allowed to take 20 items for family and friends, and all those items had to fit into a 2-pound bag about the size of a cigarette pack. So pretty much coin, you know, type thing. Had to be 1 item. I tried it. Oh, and we also could take 10 items for organizations. So I took an item for my kids' schools, and I took a corner of a Native American blanket that was presented to me by the Chippewa tribe up in Mount Pleasant. I took just a corner of that and then presented it to them later. You know, that was a nice item I got to take. And those items, basically all the items for all the organizations had to fit into this box that couple 2 or 3 feet. So there wasn't much stuff that we could take up. I tried to take up a deck of cards for the. I played bridge. It's one of my passions. And people get bridge, and I tried to take up a deck of cards. They said, well, that's 52 items. I said, okay, all right. So I took up the ace of spades, you know, gave that to those guys. I actually presented to them not long ago, about a year after the flight to that American contract bridge. But it was actually, I think, a bridge tournament here in town this week, actually. So basically, we are limited for stuff that we take up. It costs about $10,000 per pound for things to go into space. If you take the total cost of the space shuttle, the whole shuttle weighs about 250,000 pounds, and you do the astronomical math, and then it's $10,000 per pound to get things to orbit. So I guess that means I probably shouldn't have eaten that donut this morning, because I have gained about 10 pounds. I do have a trainer, a personal trainer, who makes sure that I have good diet and good exercise fitness. So as we get closer to this flight, I'll probably be a smaller box than I am now. All right, long answer to a short question. Sorry. Any other questions? Yes, sir. The question was, what does the robot do? You're talking about Mr. Dexter? Okay, we have these robotic arms, and they have little grapple pins on the ends of them, or grapple devices that grab onto a pin. And so if an item that we want to move around outside doesn't have a pin on it, you can't grab it with a robotic arm. Mr. Dexter, however, he's like a robot, so he can grab, you know, he's flexible. He can grab just about anything. He has an infinite number of ways he can grab things. So what that does is we use the conventional, you know, the big robotic arms that we had, and Mr. Dexter's on the end of it, and then he can grab around other objects, and we can then move that object to the space station from the shuttle or vice versa. We can do work out there with Mr. Dexter to grab things. So he's real flexible. And the reason we want to do that is because when Mr. Dexter can do work, then we don't have to put a guy in a spacesuit and let him go outside and get exposed to the increased risk of working outside. Plus, it's hard to get a guy outside. It takes the whole crew a whole day of work just to generate spacewalks. And so we only want to do spacewalks when we absolutely have to. Also, when the shuttle leaves, and you just leave those 3 folks, now we have 6 up there, but at the time you only had 3, it's even harder for them to generate a spacewalk. And so Mr. Dexter can do work. It takes a lot longer than human, but he can do work without generating a spacewalk. So, all right, other questions? Yes, sir? The question was, how long does it take us to get to orbit? And then once we're in orbit, that instant we're in orbit, what's that speed? And it takes 8.5 minutes for the whole, from the time you're sitting on the launch pad to when you're going 17,500 miles an hour. About 25 times the speed of sound. So once you get to flying space, you get this Mach 25 patch that I have on my uniform. The Hubble guys actually went to a higher orbit, so they went Mach 26, but we wouldn't let them have a 26 patch. Everybody just did Mach 25. But you're going 17,500 miles an hour. You know, it's 25,000 miles around the circumference of the Earth, so it takes us about an hour and a half to zip around the Earth. Did I answer your full question there? Okay, and then how long does it take when we come back? As we're orbiting the Earth at 17,500 miles an hour, it's interesting in orbit, and for the kids here, the physics of it's really interesting. You know, if you take a baseball and you throw a baseball, and it flies in an arc, right, and then it eventually comes down to the Earth, right? And if you hit the baseball with a baseball bat, you know, harder, it's going faster, right? It goes longer, but it eventually comes back to the Earth. You shoot a bullet, and it's going fast, 2,000 miles an hour or something. But eventually that bullet will come back down to the Earth somewhere, hopefully not in somebody's leg. But the space shuttle, when we get going 17,500 miles an hour, 25 times the speed of sound, we're actually falling back down toward the Earth, but we just never get there because the curvature of the fall is the same as the curvature of the Earth. So that's why we have to go that exact same speed. So we're falling toward the Earth the whole time. And I have a reason for telling you this, and that's because it doesn't take much slowing down to fall back down to the Earth. If we go that exact speed of 17,500 miles an hour, we'll stay in orbit with no thrust, no power, anything. We'll just stay there. That's what the space station's doing. But if we slow down just a couple hundred miles an hour, down to about 17.3, so we do a burn with these engines that are much smaller than the huge engines that we use to get on orbit, just slow down a little bit, we fall into the atmosphere. Just kind of dip into it just a little bit. And then the atmosphere hits us and starts slowing us down. So that whole process is kind of long, from the deorbit burn to when we land.